Okay, let's just dive right into this. We're surrounded by these incredibly complex systems all the time, right? Think towering skyscrapers, those massive underground transit networks, and all of them are held together by these hidden safety features we just never ever think about. Well, today we're going to pull back the curtain on one of the most critical, but also one of the most overlooked of them all. So, let me ask you this. If you're looking at a giant skyscraper or, say, a super busy transit station, what do you think is the weakest link? The one point of failure. Is it some massive structural beam? Maybe the power grid? Well, the answer is going to surprise you. It's way, way smaller than you'd imagine. To find it, we've got to zoom in, like really zoom in. All right, so we're heading up, all the way up to the roof. This is where you'll find these huge industrial strength HVAC units that keep all our public spaces humming along. And listen, these are not your backyard air conditioners. Nope. These things are industrial powerhouses, and they're stuck out in one of the most hostile environments you can possibly imagine. I mean, just think about the constant battle these machines are fighting. They're getting absolutely baked by the sun's UV rays, then frozen solid by blizzards. They're getting hammered by wind and rain, and on top of all that, they're constantly vibrating. Every single piece of this thing, right down to the tiniest screw, has to be tough enough to survive this relentless punishment 24/7. But you know what? As tough as the weather is, the single biggest danger, it isn't the environment at all. It's fire. See, for an HVAC unit sitting on top of a building packed with people, or a busy subway station, a fire isn't just a simple mechanical failure. No, it's a potential catastrophe. And the one little thing standing in its way might be something you've never even heard of. Okay, so here's where it gets really interesting. In a fire, not all materials are created equal. It's as simple as that. When things go sideways, the stuff these systems are built from becomes absolutely critical. Some materials can actually pour gasoline on the fire, so to speak, while others are engineered from the ground up to save lives. Let me show you what I mean. All right, check this out. This is the critical difference. Over on the left, you've got your standard everyday gasket. When things get hot, it doesn't just fail, it can start pumping out incredibly toxic gases. Now, just picture a fire in a subway tunnel. It's not the flames that are often the biggest killer. It's that thick, black, choking smoke that makes it impossible to breathe, impossible to see, impossible to escape. That's what a failing component can do. But then, look on the right, that HL3 compliance seal, it's a whole different story. It's designed to actively fight back. It holds its shape, it maintains that seal, and it suppresses that deadly smoke. It literally becomes a fire barrier. So you're probably wondering, what makes a seal that effective? How does it do that? Well, it all comes down to meeting this incredibly tough safety standard. This is where the real serious engineering comes into play. And that standard is called HL3, Hazard Level 3. The easiest way to think about it is like a firefighter suit before a machine part. It's the absolute top tier, highest level of protection you can get against fire, smoke, and toxicity. And for really critical infrastructure, this isn't just a nice to have, it is completely non-negotiable. So to earn that HL3 badge of honor, a material has to do three things, and it has to do them perfectly. Number one, it has to resist catching on fire in the first place. Seems obvious, right? Number two, if things get crazy hot anyway, it has to limit the amount of heat energy it releases. And number three, and this is the one that's all about protecting people, it has to suppress the creation of that toxic smoke. You can't just pass one or two. It's gotta be all three. And that brings us to the hero of our story, a specially engineered silicone seal. Now, this is not just any old piece of rubber you'd find at the hardware store. This is a high-performance compound that has been designed right from the molecular level up to meet every single one of those super demanding HL3 challenges. And here's how all that fancy engineering translates into real-world safety. That fire and smoke resistance, that's not just a technical spec on a spreadsheet. That's what gives people precious time to evacuate during an emergency. And that airtight seal, it doesn't just keep the rain out, it stops moisture from causing corrosion and deadly electrical failures. Then you have thermal stability. That just means it's not going to crack in a blizzard or melt in a scorching heat wave. It ensures the seal just works, period. It's designed for what the engineers call install and forget longevity, which is exactly what you want. And get this, these seals aren't just off-the-shelf parts. Nope, each one is custom engineered to fit the specific housing of an HVAC unit perfectly. And that precision is what guarantees a perfect, leak-free compression every single time. That's absolutely essential for both safety and performance. Okay, so let's zoom back out for a second. We've been really focused on this one tiny component, right? But its impact is huge. This is where we see how a small piece of engineered silicone becomes this silent, unseen protector for all of us. You've probably heard this before, but it really says it all. A safety system is only as strong as its weakest link. You can have the most advanced, most robust, most expensive system in the entire world, but if one small, critical part fails, the whole thing comes crashing down. True safety is always in the details. And that, right there, is the whole point. This tiny, engineered seal is that unseen hero ensuring the safety and reliability of the entire system. It just quietly does its job day in and day out, protecting billions of dollars of infrastructure, and more importantly, protecting the people who rely on it every single day. So here's something to think about. The next time you're walking through an airport, or riding the subway, or just in a big public building, look around. Think about all those hidden systems working all around you. What other invisible components are quietly keeping you safe right now? It's kind of a fascinating question when you stop and think about it.